$10 a year.
Okay, live stream's over. I'm taking my laptop back. Okay, it is posted. Yeah.
Okay, give me a sec.
Take your time.
Do you get tag? Was it not tag?
It's not showing.
I'll go into business with you.
Alright, here we go.
We already have science.
There's not living and everything else.
And survey.
Ready.
Survey that was like, oh, I meant to tell you to feed right.
Do you remember me the Twitter account where you retreated from?
DCI World. DSCI World.
Oh, wait, hold on.
Because it's not showing my notifications.
I wonder if it's.
Oh, I see it. Okay, cool. Reposted. Great. So hello everyone. Before I start, let me introduce myself. I'm Andrea. I'm a developer relations engineer at Ava Labs, the company that started the development of Avalanche. So my role or my mission at Ava Labs is just trying to make developers' life easier. So does anyone here identify themselves as a developer? Great. Okay, cool. Perfect. For the others, I'm trying to explain technical things with a non-technical language so everyone can understand. So the presentation here is going to be an intro to what Avalanche is and why is this important, because we are in an ecosystem where we are here because of the blockchain. So it's good to understand where are we standing. So what is Avalanche? So Avalanche is an open source platform to build scalable applications. You can create it on top of one blockchain, or you can have your own blockchain to host your own applications. So in contrast with any other platform such as Ethereum, Solana, any other blockchain out there, this is not just a monolithic single chain, but it's a network of networks with different chains on it in a kind of universe of blockchains interacting with each other. So, and something that is super important to mention as well is this Avalanche has the best time to finality, which means once your transaction is submitted to the blockchain, it is set on stone really, really fast. So for instance, if you submit a transaction in Bitcoin, you need to wait 6 blocks, around that six blocks, which is about an hour, in order to actually have some kind of confidence that the transaction is set on stone. So I was talking about the blockchain that Avalanche is and it's meant to be for scalability. What scalability means is being able, the adaptation or response of a system to adapt to a higher demand, which translates in blockchain like being able to process millions of transactions without any impact on security, performance, or cost. So one example, and I like this simulator that I'm about to show you. Oops. Sorry guys, I need to sign in because Google. Oops.
Uh-oh.
So fine.
Don't look.
Yeah, set up passkeys.
Silk.
Oh, 34.
Sorry.
Silk.
Silk plus
Sorry.
passkeys. All right, we still have a ways to go.
Well, I was saying, so the scalability thing, and I can put this while my phone charges. Is this straight? Yes, this is me. TX down. It was, what number was it?
Carlos.
34.
What?
Great.
No.
What's this?
What?
TX down.
Oh, TX3.
Great.
That's the bus thing.
You like this one?
Yeah, he was asking us yesterday, which is the Ethereum bus transaction simulator thing.
Yeah, I love
I
this
didn't
one.
remember it.
Yeah, so they changed the link. But anyway, the thing is, like, this simulates a blockchain. So each of these ones is just one block. And all these, if you actually click this, is a transaction that is pending to get into the blockchain. What is interesting is to see the line of transactions pending, just waiting for the gas to be low enough to get processed. Actually, this is longer, but I don't know why it's not like actually loading here. But anyway, the thing is, like, if we're thinking of bringing all these solutions to a blockchain, we need some infrastructure that can accommodate that kind of usage. So what happened when we have these high demand? We have like network saturation, we have high cost, because you will start prioritizing the transactions that are willing to pay more to get up front of everyone else. And also you have a high waiting time if you are not willing to pay that much. So there are two ways to scale as but anything else is just better the resources that you already have, which means the consensus level or how the different computer changes communicate to each other on the virtual machine, the database, whatever. It's just optimizing at the very the resources that already exist. And horizontal scaling is creating more resources. So you can see it like trains, like having vertical scalability means like improving, but in order to actually improve and scale to make trains faster, cleaner, or whatever, you actually need to focus on the core technology. You need a great innovation in here. So right now, in this example, you have innovation on how the train actually works. And the horizontal scaling is just creating more trains. So what Avalanche is, or how you can see this, is being optimizing each layer or each blockchain independently, and also combining the horizontal scaling via creating different block spaces, making it fast, low cost, scalable, and you can also customize the blockchains. And this the customization of blockchains is something that could be really suitable for different use cases that are not currently coming on blockchain because the rules are already set, and I'll get into that in a minute. So regarding the vertical scalability and how this is actually achieved by Avalanche, one of the most important innovations in the consensus protocol is the consensus that Avalanche implements, which is Avalanche Consensus, and it reached finality of under a second, which means your transaction, as I said, is set on stone. It's not reversible. You cannot have any reorg of blocks, and under the second, you will be sure that the information that you put it there, it's already there forever. It reaches highest decentralization. Right now, we have over 1,900 validators, and you also have. Has anyone here heard about the 51% attack?
Yeah.
Okay, well, with the Avalanche consensus, you can reach an 80% security threshold. Yeah.
So it means someone has to capture more than 80% too.
Yeah. So the thing is, like, the consensus protocol works with a subsampling of the network,
Right.
and repeated subsamples until you reach some threshold of confidence that the whole network is just converging to the same state.
I have a question. Is Avalanche architecture thinking of growing mainly through C chains and through subnets
Yes.
rather than C chain having more transactability?
We do have, actually today was posted on Twitter, the roadmap, and we have like three main goals. One is like single chain scaling. Another is reaching 1,000 of transactions, and the other one is just make the system reliable.
And which one, but right now the focus would be like growing it sideways rather than making.
Or vertical. Yeah, I would say both are on the works. So we do have one. It is called Hyper SDK. It's an SDK to create virtual machines, and right now it is not focused on the EVM. But the idea is at the very end to finalize giving the EVM the power of these new upgrades, let's say, and optimizing it.
And in this case, the EVM is sort of like Ethereum has a proofs of the roots. It has a root of the L2.
Yeah.
Is the C chain like securing the other chains?
No, I'm gonna get into the architecture actually now. Yeah. So Avalanche, as in the very beginning, it started with 3 chains. It was the X chain. It's just like for creating assets and just transfer them. It's not so interesting, to be honest. The P chain, this is a great chain because this is not like the chain on Ethereum where you receive the transactions, but it's a chain that the only thing that it has is validator information. It has whose validators are validating which chains. So it's just kind of like a record or who's where.
And a validator is, in this case,
A computer just running Avalanche Go and syncing the information of these three chains right now. So there's an ICP or an Avalanche community proposal making the X chain and the C chain optional for validators. But a validator, and why it is called a subnet, it is because you have the whole universe of 1900 validators right now, and if you choose a subset of it, they can start validating extra subnets, right?
And
extra chains.
if it's optional, like if those chains are optional, does their security guarantees change?
Yeah, so the idea is like on the subnets has their own security independence from the main chain, in the sense of and this is desirable and by design, because what you can do, and something that I like to think about is, like, for instance, in Europe, if you want to put some data on, or for instance in Mexico, and from Mexico, if you want to put some governmental information on servers such as AWS, you cannot do it if the servers are not in national territory. So that it makes every use case of that has these requirements not possible on any blockchain that is distributed worldwide, which is really lame, because right now you would need to launch your own blockchain from scratch, which is not desirable, because then you lose the property of being communicating to a whole ecosystem with liquidity everywhere. So you can launch a subnet and you can customize a set of validators that are going to be securing your network. Also, if you want your validators to meet certain conditions, you can do it. So any, I don't know, like licenses or whatever. But yeah, the security is independent in each subnet.
But why these three? Why X, P, and C? Why not X within C or P within C?
Yeah, so the thing is where the information is going to be, what kind of information are you handling? The C chain is an EVM chain, which means you have full compatibility with Solidity, all the EVM smart contracts and tooling, which is nice, because most blockchain developers right now is where they go. The P chain has its own virtual machine, which just handles the recording of validators, signatures, and subnets. And this is a chain that will allow us to communicate between two subnets in a secure manner without having a third party that we need to trust, like in any other bridge. So actually, the cross-chain communication between subnets is really nice and secure, but we won't get super deep into it right now.
So the C chain could be a custom subnet.
Yeah, you can actually launch your custom subnets on EVM, which is called subnet EVM. And you can launch it. We can actually launch one in 10 seconds or so. We can do it afterwards if you want.
D sidechain?
Yeah, we can do it. Let's do it.
There's a few of those already.
Yeah. You will see how easy it is to launch your chain, because when you are trying to launch your chain from scratch, it's just like way too much to know before you can actually do it. From gossip protocols to like network level kind of configs, everything, and this makes it way easier and keep you connected to the broader ecosystem.
Can I ask one more question?
Yeah, sure.
How is this related to substrates or the Polkadot ecosystem?
Yeah, so the Polkadot ecosystem has a different architecture. So the Polkadot has different chains, the parachains, and they all connect to the relay chain. So you have like a single place where all the information settles. This has two difficulties, I think. One is that since you are having everything to go through the single point, you have single point of failure and also a bottleneck. And the other thing is this chain, the relay chain, is going to have some limited capacity. While in here, if you just want another chain, you can launch another L1. You just need to put some validators on.
You don't have to bond dot or anything like that.
You need to what?
You don't need to like bond dot or win an auction.
No. Right now, I mean, actually, the subnets can scale to thousands of subnets without any issue. There's no like limited capacity, because again, you're not writing any information, let's say, to the C chain. You can have your own information in your own L1, and this is great also for privacy. Like if you want to have some application that requires some specific privacy settings or whatever, you can have that on your own settings, on your own chain, and then connect to other chains just for the information that you want to receive or send to any other business chains, areas, or whatever.
These subnets, are they self-governed by their own token, I guess?
Yes. Okay. So yeah, that's good.
Then, like, how do they connect? Because let's say I'm running a P chain validator, right?
Yes.
And people will release a side chain on which proves itself to that validator.
Yeah. So in order to validate, if you are a validator, there are two kinds of subnets: elastic subnets and private subnets, or well, not permission subnets. So the permission subnets require to whitelist the validator ID on the P chain, so the validator can assign themselves to that subnet as well and start receiving the information and validating that information. On the case you need to whitelist the node ID for the permission ones. For the elastic or permissionless, you as a subnet operator, so every subnet burns at the very beginning is a permission subnet, and then you need to submit a transaction that you want to transform that subnet to elastic, and when you submit that, you need to specify which token the NFT needs to stake in order to start validating your subnet. Why? Because you need a mechanism to protect your network against any attack.
And these loads, but how does so I have a permission subnet, and then I want to
open it.
Yeah. And after that happens, other people can validate this.
Yes, and you lose control of who can validate or not. It's the rules.
But if there's new validators, because there could be a state where there are no new validators because whatever reason, and I still have like the control, right?
You mean before transforming into elastic?
No, let's say we transform.
Yes.
And anyone could validate it,
but no one
shows up.
Yeah.
And I'm still the only validator.
Yeah, in the sense of like you are the only validator, yes.
Yeah. And does my data is now pushed to the P chain?
No, your data is never pushed to the C chain.
And what's the relationship between the subnet and the P chain?
So because of that has to be with cross-chain communication. So imagine, for those not technical, let's imagine we have two towns. So imagine you want to send information to the C chain or to another subnet. So you have two chains. You want to send a message. And so the first thing you need to check when you receive a message is that it is signed for someone.
Right.
But who is that, or what signature you must be looking for? That is the question, right? Like, so the idea is, because you are validating the P chain, you know which signatures you are looking for, because you know who is validating the other subnet.
Okay.
On the other cross-chain communication protocols, such as CCIP, you trust a network of CCIP, the CCIP network. You know, you don't trust your own P chain or your own data or the source data, the source chain that you're already trusting. So that makes the protocol super secure, in the sense of like you're a third party on a cross-chain communication protocol. It's the other side. It's not a third party.
Right. So that's for secure bridges between chains.
Yeah.
And now this means that every individual subnet, we have to evaluate its security profile individually, because if I have a subnet with 3 nodes, getting 80% is kind of easy. You can get 100%, right?
Yeah. So the thing is, like, you can create, if you want to settle on a C chain, you can create that with cross-chain communication protocol, and you can just set the hash of the block or whatever into the C chain, which is totally fair. In fact, there are subnets that are building L2s for Ethereum, so are setting on Ethereum information. So what a subnet really is just a set of validators that agree on some state. What is that state? What does that do? It doesn't really matter.
Right.
But yeah, I mean, the thing is, like, if you're launching a subnet and it does not have any incentive for the validators to come and validate, then no one's gonna validate your subnet.
Right.
Which means, like, in order to actually for you to build a subnet, you need to have some sort of incentives, especially if you're gonna make an elastic subnet. If you are keeping that permission, then there's not such a you have your own incentives, or probably the institutions have their own incentives to keep that private and running, right?
So you would say Avalanche, because I really like the fact that you can make a subnet and the security guarantee would be actually on Ethereum from layer 2, but Avalanche positioning itself as an interchain communication between subnets and whatever they're connected to seems to be a very interesting place to be in as like core infra for like the space.
Yeah, so the thing is, like, when you launch a subnet, you can also customize every level of your chain. As I said, like, this can be an EVM, but it also has a hybrid SDK, which we have one virtual machine built on Wasm, where you can program in Rust. You can have different kind of optimizations. And for instance, one thing that I really like about hybrid SDK is this dynamic fees. So right now, like, I don't know if you've seen what happened with the EVM with inscriptions, that people were just launching transactions with that didn't use like process or change the state.
Just
They were
strings.
But there were resources that weren't being used, but the gas was just uniform across the different resources. So one way to actually isolate the effect on the different resources that the transactions are happening is with dynamic fees, and that is included on hybrid SDK. So just for say some of the things that are being worked on the hybrid SDK at the virtual machine level.
Do you have a subnet that comes built in with LP Stack?
No, we so right now the focus is subnet EVM and hybrid SDK. That's the main focus, but we do have teams working in different fronts, such as the Wasm one, and I think there's another one with Move, such as Sui, that kind of chains. We do have some other. That is the one that settles on Ethereum. I think it's Movement. You can check that out. Huh?
The Sui one.
No. Yeah, the Move one. The Sui uses Move as well as Movement. Movement settles on Ethereum, but it's a subnet. So this is how the testnet looks like. The different chains are there. So one validator can belong to multiple subnets, and a subnet can validate multiple chains. So what is cool about subnets is you have the independence of traffic, which means like if Taylor Swift launch an NFT or whatever, your game is not going to be affected, which is really nice to have. Also the customizations,
And is that true because you don't need to overlap?
Yes, you don't need to settle information on the C chain.
I see.
Yeah, I mean you can if you want, but if you don't want, you don't need to.
Will the subnets share validators?
It depends. Like, let me show you actually a map of on subnets, because I think it's really illustrative. Yeah, so these. Okay, so the red dots are validators. So they belong to different subnets. The gray areas are the subnets, which subnet, as I said, is just a subset of validators. So one validator can belong to different subnets. One subnet can validate multiple chains. One chain is it's only validated by one subnet. Okay, so yeah, that's how the validators.
I see.
Yeah. Okay, cool. So yeah, you have independence and you have also customization. Like if you want to have your chain work in some way, you can do it. If you want to have, even if you want your subnet not to work with chains, like as we know, you can do it. We have heard a lot of ideas of what if we create an Oracle chain, something that broadcasts the Oracle to different chains. And yeah, you can build anything. As I said, the subnet is just a subset of validators that agree on something. And regarding the thing of that you were saying, that we do need a gas token for our chain. So when to build on a subnet, because you now have different ways to build, right? On top of the C chain, which is the EVM where everyone is deployed, or deploy your own subnet. So if you want your own gas token, then you can go to a subnet. If you want some access control, like who can participate or who not, you can go to a subnet. If you require some virtual machine customization as well, if you are expecting to have a high throughput, this is really suitable for games. We actually have AAA games launched on subnets because, again, you cannot deploy where probably someone is launching a mint and the gas fees are going to be spiking all over the place, just affecting the UX of your users. And also for regulation, if, as I said, the case of the Mexico government that doesn't allow to put information in different servers, you can have, in this case, a KYB or know your validator that follows some specific regulation in order to actually process the transactions. So that kind of thing, or a KYC as well. So we have some institutional adoption as well. JP Morgan City has some proof of concept on Avalanche because of that.
Has anyone done a civil resistance subnet where to get in you have to do a proof of humanity?
Not that I'm aware. No, not sure. Not to be honest. But that would be nice because then you can consume that information of who's a human into another applications.
Yeah, that's what I'm wondering.
Yeah, and you do that with the cross-chain communication protocol that we have, so you don't need to trust anyone else that you are giving the information.
Okay.
Yeah.
Gotcha.
So yeah, that's it. If you want to follow, we do have an academy. If you want to go deeper, it is meant to be for developers, but we have one specific course that is Avalanche Fundamentals, which is really not getting into the code. But let's do the DeSci subnet real quick.
Yeah.
Yes.
I was going to ask, how much does it roughly cost?
How much is it? What?
Does it roughly cost?
So, in order to put a validator in the chain, just to belong to validate the key chain, let's say, you need 2,000 AVAX per validator.
Nice.
Yeah.
Per validator.
Per validator. We do have a service that is called AvaCloud, which help you launch proof of concepts on subnets. So it's basically like a AWS. So you can just start ready, and so you don't need to host the validators.
And does each validator has to? So if I have a subnet, I get one validator for that amount. Does then every new validator has to post the same sort of bond to validate my subnet, or is it once per validator on the network?
No, so the validator gets into a network as PX and C chain. It start validating those three, and you in your subnet can have your own requirements. Like
Right.
you can say like, so every subnet validator is a validator of the whole network.
Okay.
So they need to put that 2,000 AVAX.
Mm-hmm.
Does every
Which is
subnet
$80,000, by the way.
Yeah, 80,000. I was thinking. Does a subnet? Every subnet needs a validator.
Yes.
So to create a new subnet, you need to basically stake $80,000 worth of data.
Yeah, for to enter the network, and if the subnet requires any other kind of bond, they can ask for it.
So my point being, validators and subnets are separate, but they're required to be to launch, right?
So subnets are just a set of validators.
Right. Okay.
Yeah.
So
Validators
if we
are
want to launch a DeSci World subnet right now, would we have to stake $80,000 worth of data?
yes
Yeah.
per validator.
Unless a
It
validator,
was willing to come on and take on that.
right? If a validator gives you their key or something.
What? Sorry, again. What is
Say
it?
you were running a validator and then you really like DeSci World and you said, I'm going to run your subnet.
Yeah, all those 1,900 validators can start validating your
Okay.
subnet.
Without spending any extra AVAX.
Yeah, exactly. You don't need it to be the one that runs the validators. You can incentivize someone else to run them.
Doing their job.
But they need, but that means that they need to, for example, if I have like a subnet that has a lot of activity and like transactional throughput, would that make it? And let's say I'm not giving an incentive because it should be for selfless validation. Just think about it. Does the H validator that joins has to see all the transaction data and therefore all the increased throughput, because basically a validator is deciding how many chains they can validate with their current setup, right?
Yes. Yeah. Of course. Like if So a validator will be able to just validate a bunch of subnets. It cannot validate everything because
And could validators drop me if I get too big and I'm being a hassle to validate?
I mean, the thing is, like, a validator, in order for a validator to start validating, the incentive needs to be higher than the cost.
Right.
That works in every economic system. So yeah, if you're not giving enough incentives to validate, why would they?
Right, but they can drop me at any point.
No, so the thing is, when you start validation, and I don't really know if this applies exactly for subnets. I need to check, to be honest. You commit to a certain specific time, and so on the main chain, that time is 2 weeks up to 1 year.
Okay.
So you set that up front, and you block your tokens at the very beginning, and will be unlocked afterwards. The thing is, you will gain some incentive after the period finalizes. And if you have, and I'm talking again about the primary network, if you are responsive enough. If not, you're not getting the incentives. You won't be slashed, which is nice, but you won't get the
Okay.
Like a bonus.
So
What
I can
about-
have a situation where, let's assume it's like that for subnets. I know my validators are going to on stake because maybe my token crashed, right? So it's not worth it anymore. Would if enough validators on stake, then the chain becomes even at 80%, it becomes vulnerable to majority attacks, because another set of validators could say, hey, well, what if we just like rob these guys and empty the chain, because there weren't enough validators active, so it's economically interesting to do 80%.
Yeah, it's like any other L1. If you are not interesting to be validator, you can have.
But the problem is that since it's so hard, like there's such a high bar to become a validator, when you make a new subnet, you basically are beholden to the whims of the validators to connect to you. And if your data, it's all about your data gets too high, it's not cost efficient anymore, you get dropped. And then, I mean, it's cool as a game theory incentive, but I'm just trying to understand how I would evaluate individual networks.
Yeah.
And their potential to be exploited by not being incentivized enough for validators.
Yeah, so the what Avalanche allows you to do is to launch your own L1. The economic thing, the part of the incentives and how you are bringing value is case specific. So it does, like, in order to actually have some interest from validators, as I said, the incentive needs to be higher than the cost, and it creates a market for validators.
So every chain has their number for where it's economically viable to attack it then.
Yeah, in the sense, like, but those attackers need to be a validator
Right.
on the primary network as well.
So in this instance, what's the ratio of private to private to elastic chains in Avalanche?
Yeah, so right now, there are many permission subnets, but we are just waiting for some activations to happen in order to become elastic. But all subnets launch first as permission.
So in the case of Carlos's word here, if I'm running a permission blockchain, I don't really care about the.
You don't care about that. No, this is in case
You
of
have to
elastic.
trust the person running the
Yeah, but so for example, most entities will probably run their own validators and front the costs for the validator. So you don't have to worry because it's internal to yourself or your network participants that are incentivized outside of the chain.
Right. I mean, that's as long as it's permission.
Yeah.
But if you want to have
That's what I mean.
any sort of permissionless system, like, you have to ensure that it's forever, because a chain cannot become, once it's permissionless.
It cannot become permission again. That's true. Yeah, but that is true. I mean, if you are willing, or if you are thinking to open your network, you need to make sure that you have the incentive set for that to happen.
Yeah, most of the subnets that I've seen online
and those permission networks
are not elastic.
And those permission networks cannot, like, for example, use cross-chain communications from the P network.
No, they can. They all can communicate. It's just who's validating that information.
Okay. So it's trusting the person running the service, basically.
In the sense, like, if you are gonna go for a permission one, you are trusting the validators as in any other network.
And if they go broke and they can't pay for a server cost anymore, it's over.
Yeah, like it's in any other L1. If the validators or
Right, but
just shut down.
That's why you make a network. You have a validator of one, so it's basically as long as that person can keep their permission.
Yeah, you need at least one validator to have the information there.
Right.
Yeah, because they are the only one that has the information. If you don't have validators in a subnet, then the subnet doesn't exist.
Right.
Yeah. But yeah. But yeah, I mean, the thing is, like, you can create whatever you want in the sense of, like, if you want to be permission, you want to be permission. If you have the right incentives in your economic model to actually become permissionless, go elastic. Yeah, and you can also, if you want to be super sure about the information being also committed into some other chain, you can do it like as an L2 as well. But anyway, let's do our DeSci chain. So we have a client which is Avalanche CLI. Let's go Avalanche subnet create.
Can we call it the node chain?
No.
Can I what?
Why not?
I wonder if this is
What name you want?
Node chain.
Node chain.
Yes.
Great. And this is gonna guide us through a wizard. So here's where we are selecting the virtual machine. This is gonna be a subnet EVM. And now we need to put an ID. This needs to be unique. But we're deploying local, so we just put. Huh? What you said?
No worry.
Okay. So the chain ID, and then we put the token symbol.
No.
Nerd. Cool.
Who's buying?
We're using the latest version, and this is where you customize the gas fees. In the sense of how, gas is there because they want to protect the network of spam or DDoS. So if you are not using or you are not having probably super high throughput, or if you're just being conservative with the gas, you can go with low disk usage, low throughput. If you want to go doing something like way crazier, you can configure this as having bigger blocks, having more transaction accepted, more gas being accepted, but we're just going with this. This is just in the Genesis block, you need to config who's receiving the funds at the very beginning. Right now, we will use a default address where we will get the key. And now, would you like to ask a custom precompile? This is like for, I'll just show you where it's in here. Like native minting, you can mint your own native token via contract. You can have an allow list for transaction. You can manage the fee settings via contract. This is modifying the EVM. This is not at an application level.
Is this upgradable after you deploy?
Yes. Reward manager. This is the reward you're giving to your validators or whatever. And cancel. I don't want that. Okay, perfect. We have our chain, and if we go Avalanche subnet list, we will see the nerd chain and a couple others that I have. Nerd chain, it's here. And then we go Avalanche subnet deploy nerd chain. And it will ask us if you want to deploy local, DevNet, Fuji, or mainnet. We go local now. And this is launching 5 nodes of Avalanche Go just running on my computer, deploying that chain. So once we have that deployed, we will be able to connect to our MetaMask or our wallet and start using it.
Is the local network useful for sort of testing?
Yeah. If I turn off my computer, the network is down. Yeah. No.
Can other people connect to this from your laptop?
You will need to expose the ports. Yeah, but it's not meant to be for this. To be honest, it's just like real quick testing.
Sure.
So it gives you an RPC of one of the nodes. It actually gives you 5 because we have 5 nodes. And then we can start connecting our tutorials.
Have you done any experiments in like just-in-time blockchains for events and such?
For events, sorry?
Like you create a subnet that has a lifespan of say 7 days, and then it settles and it's.
I've launched DevNets for testing different virtual machines on that
blockchain. It's an interesting case for Avalanche where you have like a gathering of people, and then they all transact with each other, and then you sort of settle the chain, like make it final, and then
We actually deployed one because we on the academy we have we were doing this transition because the cross-chain communication protocol just activated on Fuji, but the academy content we needed to make it like without hiccups on this transition. So we created a DevNet, migrate the content to this DevNet that was independent from Fuji or mainnet. So yeah, I mean you can do it.
I think that's a cool use case.
Yeah.
We could have done that in here
But yeah.
next time.
So we add our RPC to our wallet. We put the information of the wallet, which is of the chain, sorry, which is nerd chain 12398. The token symbol was nerd.
Nice.
I already have some. Sorry, I use the same
Number.
the same number for every because I already know it's unique. Delete. Custom add nerd chain 12397 nerd save. Great. We now have the network added. We are in there. We have it keeps some cache of this, but anyway, we can start sending our nerds. I imported the account, so this is the account that it has in the Genesis block by default. It gives you the private key. Never ever use this private key in production, and we can start sending some tokens, some nerd tokens to any other wallets. So let's use another account, and we send this amount of tokens. Send now. Great, and it was sent successful, and it's finalized now.
Nice.
So yeah, that was it, and then we need to just avalanche network stop just to stop the network, and that's it.
It was good while it lasted.
Very cool.
Very cool. Does Avalanche Labs offer support with the validator costs?
We have some the Ava Cloud team. It's one way, and yeah, we can support you